In this video, we will review how to perform translations, reflections, rotations, and dilations. So let's start with translations. A translation is where you just slide a point across the plane. So we're going to be talking about up, down, left, right. If we are moving left 3 units, that's going to be affecting the x value only. So that's going to be x minus 3 to the left 3. The y value will stay the same. So if I apply that to this point, that means I'm going to subtract 3 from the x value. So that'll be 5. The y value stays the same. So if I want to move to the right 3 units, instead of subtracting 3, I'm going to add 3 to the x value. The y value, again, will stay the same. So now I'm adding 3, so that's going to give me 11, negative 1. Now, if we were moving up or down, that's going to be a y value change, all right? Up and down is the y value direction. So up 3 units, we will add 3 to the y value. All right, so the x value is staying the same. And if I add 3 to the y value, that gives me a positive 2. On the other hand, if I move down 3 units, then I will have to subtract 3 from the y value. So that would be the rule. X value stays the same. Subtracting 3 from the y value, negative 3 and negative 1 makes negative 4. Let's talk reflections now. If we are reflecting across the x-axis, the rule is x opposite of y. If we reflect across the y-axis, the rule for that is opposite of x, comma, y. If we reflect across the line y equals x, that's going to be y, comma, x. And if we reflect across the line y equals negative x, the rule is opposite of y, opposite of x. Now, all of these rules I just quoted, this is something that you need to memorize. So if you have not memorized these rules yet, go ahead and pause the video and just copy these rules down and memorize them. Now let's just apply these rules to these points. Well, I guess it's the same point over and over again, but you know what I mean. Notice how I say the opposite of y and the opposite of x instead of saying negative y or negative x. If you get in the habit of saying negative y, you're going to think it's supposed to be a negative number. But that is not necessarily the case. If you say the opposite of y, it will remind you to simply change the y value to the other sign. So here we go. X opposite of y. X is 8. The opposite of y is 1. Opposite of x, y. The opposite of x is negative 8. Y is negative 1. Yx. Y is negative 1. X is 8. Opposite of y, opposite of x. Okay, the opposite of y is positive 1. And the opposite of x is negative 8. All right, let's do rotations around the origin. Here are the 3 rules that you need to memorize. To perform a 90-degree clockwise rotation around the origin, the rule is y opposite of x. To do a 90-degree counterclockwise rotation, the rule is opposite of y, x. And to do a 180-degree rotation, the rule is opposite of x, opposite of y. You simply must memorize these rules. If you haven't memorized them yet, pause the video, copy them down, and study them. Now let's apply them to the point 8, comma, negative 1. So y is negative 1. The opposite of x is negative 8. The opposite of y is positive 1. X is 8. The opposite of x is negative 8. The opposite of y is positive 1. Now let's do dilations, stretches, and shrinks. All right, a dilation is when you take a shape and you make it bigger or smaller in all directions. And maybe I'll skip down here. If there's a scale factor, if the scale factor is greater than 1, it's going to be an enlargement or a stretch. Okay, so if the scale factor is greater than 1, it will be a reduction if the scale factor is less than 1, or a shrink. Okay, so a dilation by a scale factor of 2, all you do is you multiply the x and the y by 2. So if I apply that to this point, that will give me 16 comma negative 2, just multiplying everything by 2. All right, so notice that a dilation affects the x value and the y value at the same time. But here they say a horizontal stretch. A horizontal change is only going to affect the x values. So when you see horizontal, you should be thinking, okay, x values. So since the scale factor is 2, we will multiply the x value only by 2. The y value will stay the same. So if I do 2 times 8, that's 16. But in this case, the y value will just stay negative 1. Similarly, if we do a vertical stretch, as soon as you see the word vertical, you should be thinking, oh, this is only going to affect the y values. So the x value will stay the same, and we will do 2 times y. So that means I'm going to have 8, but then I'll multiply negative 1 by 2 and get negative 2. Now, if I want to reflect across a line other than the x-axis or the y-axis, first of all, I need to know what equations like y equals 1 looks like. So please understand that y equals 1 is a horizontal line. Okay, meaning it's going to be like this. And x equals a number is a vertical line. Like this. So anytime you see y equals a number, horizontal, x equals a number is vertical. And yes, that's the opposite of what you might have thought, because we know that the x-axis is horizontal, yet the line x equals 1 is in fact vertical. So let's take a moment and graph the line y equals 1 and the line x equals 1. So it is easiest to do these reflections visually. So if I reflect point B across this line, I notice that point B is 1 unit up, so B prime will be 1 unit down from the line. Point A is 2 units up, so point B will be 2 units down. So this will be A prime, and this will be B prime. Similarly, I'm going to now reflect over this vertical line. Notice that point B is 3 units to the left, so I'm going to have to go 3 units to the right for B prime. Point A is 1 unit to the right, so I'm going to go 1 unit to the left. So this will be my A prime and my B prime. Notice how the images are mirror images of each other with this reflection line going right down the middle. Same here. These are mirror images of each other across this line. So now it's time to do a 180-degree rotation around the origin. Remember, the rule for that is a general point x comma y becomes opposite of x, opposite of y. So that is the rule we will use. Point A is the point 2 comma 3. And point B is the point negative 2 comma 2. So I can use the rule to find A prime and B prime. The opposite of x is negative 2. The opposite of y is negative 3. The opposite of x is positive 2. The opposite of y is negative 2. So let's see, negative 2, negative 3 would be right here. That'll be my A prime. Positive 2, negative 2 would be right here. And that will be my B prime. Okay. Similarly, if I want to do a 90-degree clockwise rotation, the rule is xy becomes y opposite of x. Points A and B are still 2 comma 3 and negative 2 comma 2. So let's use the rule. Y opposite of x. Y is 3 and the opposite of x is negative 2. Now B prime. Y is 2 and the opposite of x is positive 2. Let's plot these. 3, negative 2 would be right here, so that's going to be A prime. And 2 comma 2 would be right here. So this is A prime and B prime. All right, and then we'll just draw the line segment. So let's do some dilations. If you want to dilate from 0, 0 by a scale factor of 1/2, all you do is you multiply 1/2 times both the x value and the y value. So half of 2 is 1. Half of 3 is 1.5. All right, half of negative 2 is negative 1. And again, half of 2 is 1. So we have 1 comma 1.5, which would be right here in between the lines. And we have negative 1 comma 1. So this will be our new A prime and B prime. So this teeny tiny little baby segment is the dilation. And that's what dilation does. This 1/2 is the scale factor. If the scale factor is less than 1, the figure gets smaller. And if this was bigger than 1, it would get bigger. So this time it's going to get bigger. It might even go off the graph, but that's okay. So again, when you dilate by a scale factor, you just multiply the x value and the y value by that scale factor. So that means A prime is going to be 4 comma 6 and B prime is going to be negative 4 comma negative 4. So A prime is going to go off the graph a little bit, but that's okay. So 4 comma 6 would be about, okay, so this would be about 5, 6. All right, so that'll be A prime going, whoops, off the graph a tiny bit. But that, take my word for it, that's A prime. And then B prime is going to be -4, comma, -4. So, wait, did I say -4? This should be -4, +4. Let me just, I'm just going to make it plus. Okay, so -4, 4 is going to be right here. So that'll be our B prime. Okay, and there it is. All right. That's how you do a dilation. And finally, let's talk about mapping a figure onto itself. So if you want to map a figure onto itself using reflections, you are looking for a line of symmetry. So let me see if I can draw a line of symmetry real quick. So can you see that this line that I'm about to draw, can you see that this line splits the square right down the middle? So that is a line of symmetry. So if we did a reflection over this line, the square would fall back on itself. The left side would reflect and become the right side. The right side would reflect and become the left side. So that's what it means to map a figure onto itself. Now, we have learned that a vertical line always has the equation x equals some number. And this is a vertical line at 1, so this is the equation x equals 1. This is the line x equals 1. So we can say a reflection over x equals 1. So that is one reflection that will map the square back onto itself. But there is another line of symmetry. If you look carefully, can you see that the x-axis splits the square right down the middle horizontally? Okay, so the x-axis is also a line of symmetry, so therefore we can say reflection over the x-axis. All right, so that is how you can find a reflection that will map a figure onto itself. I should mention that sometimes there will be a diagonal line of symmetry. For example, this diagonal line is the line y equals x. But this is not a line of symmetry because we do not have mirror images on either side of the line. Can you see that there's more of the square below the line than there is above the line? So that means it is not a reflection line. Similarly, the line y equals -x is not a line of symmetry either, because more of the square is above the line than there is below the line. So these are the only two lines of symmetry.